Hello everyone, this is Poisson, a 9-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve a couple of problems on Poisson's ratio. So this is the problem over here. So you can see the problem. There is a circular aluminium tube of length L is equal to 600 mm. Is loaded in compression forces by P. So this is the compression force. The outside and inside diameters are given, means it is a hollow cylindrical tube actually. So a strain gauge is placed on the outside of the tube to measure normal strains in the longitudinal direction. What is strain gauge? Strain gauge means there will be some thin wire of some length L dash that is attached to this aluminium tube. Then whatever stretch it will get, suppose this will become L plus delta L dash. So then the strain will be delta L dash divided by L. So it will measure this strain gauge here. So that will be is equals to the change in length of the circular aluminium tube divided by the length of the aluminium tube, right? So this is about strain gauge. Means we won't measure what is the change in length of the circular aluminium tube, but this strain gauge directly gives the value of strain. Okay. So assume E is equals to 73 gigapascals and Poisson's ratio 0.33. The first question over here is, if the compressive stress in the tube is 57 megapascals, what is the load P? That is very simple for part A. Compressive stress sigma C will be is equal to what is the value? E into epsilon, right? Not E into epsilon, we can write P by A. So we already know 57 megapascals, and this will be minus P divided by A will be pi by 4 D square, D2 square minus D1 square, right? So P will be is equals to minus 57 into pi by 4 into 75 square minus 63 square. So let us put it in calculator. So 57 into 3.14 into 75 square minus 63 square divided by 4. So we get 74097.7 newtons. So that will be is equal to nearly 74.1 kilometers, right? So this is about first question. Let us go to second question. So the second question is, if the measured strain is given, means this strain gauge is measuring the strain epsilon. That epsilon is given here. That epsilon is 781 into 10 power minus 6. What is the shortening delta of the tube? What is the percentage change in cross sectional area? And what is volume change of the tube? So let us go ahead. In this case, we already know the epsilon, right? That epsilon will be equals to 781 into 10 power minus 6. So we need to find out delta. So see, delta by L will be equals to epsilon. So delta will be equals to epsilon into L. That will be 781 into 10 power minus 6 into 600 mm. So delta will be shortening. This will be shortening. So 781 into 600. So we get 0.4686 mm. This much is the shortening. So see, next, what is the percentage change in its cross-sectional area? Poisson's ratio is also given. Okay, we need to understand one thing over here. See, initially the circular tube is like this. So now because of the compressive force, the diameters will increase. So this diameter will something go to like here. This diameter will go to here. So this will be final. You understand the situation. So initial diameters are d1 comma d2, final diameters are d1 dash comma d2 dash. So we know epsilon is given by 781 into 10 power minus 6, right? So and from that we can get nu is equals to minus epsilon dash by epsilon. So as we already know that the epsilon is negative, this should be negative because it is compressive. So epsilon dash will be positive. So let us take all positive, then epsilon dash will be equals to nu into epsilon, right? So this is epsilon dash. So then final diameter d1 dash minus d1 divided by d will be is equals to epsilon dash. Similarly, d2 dash minus d1 dash divided by d will be is equals to epsilon dash. Then d1 dash will be 1 plus epsilon dash into d1. d2 dash will be 1 plus epsilon dash into d2. We need to find percentage change in area. So that will be del A divided by A. That will be equals to pi by 4 d2 dash square minus d1 dash square minus pi by 4 d2 square minus d1 square divided by pi by 4 d2 square minus d1 square, right? This is the formula. Pi by 4, pi by 4, pi by 4 gets cancelled. So del A divided by A will be is equals to, you see over here, it will be d2 dash square minus d1 dash square divided by d2 square minus d1 square, right? Minus 1. Okay. So this will be equals to 1 plus epsilon dash d1 square, sorry, d2 square minus 1 plus epsilon dash d1 square divided by d2 square minus d1 square minus 1. So this will be 1 plus epsilon dash whole square to d2 square minus d1 square divided by d2 square minus d1 square minus 1. So this will be is equals to 1 plus epsilon dash whole square minus 1. That will be equals to 1 plus epsilon dash square plus 2 epsilon dash minus 1. See, we already know that epsilon dash, epsilon, these things are very small. So we can neglect epsilon dash square, right? So this should be nearly is equals to 0. This one gets cancelled. We get 2 epsilon dash, right? Epsilon dash is change in diameter. For change in cross section area, we are getting 2 epsilon dash. So what is 2 epsilon dash? Do you understand? See, epsilon dash is del d divided by d, right? So 2 epsilon dash is del d square divided by d square, right? So this is del A by A. This is del L by L. See, because these are small changes, we can get this as this 2 epsilon dash. Okay. So we already know epsilon dash 2 into what is nu, that is 0.33 into what is epsilon 781 into 10 power minus 6. That will be is equals to del A by A. So del A by A will be is equals to, let us put it in calculator, 2 into 0.33 into 781. So that will be is equals to 515.46 into 10 power minus 6. If we want percentage, we need to multiply it with 100, right? So that will be is equals to 0.0515 percentage. Okay. So this is percentage changing cross sectional area. So now if you see the question in part B, they also asked the volume change of the tube. Then how will you calculate? C for B may third part. See, you can write it delta V by V will be is equals to, can we write it as A into length L divided by AL, right? This is initial one. So this will be is equals to del A divided by A into, can we write it like this? So this will be D of AL divided by AL, right? So this will be DA into L plus L into DA divided by AL. So that will be is equals to dA by A plus dl by L. This is dl, this is A. Okay. So what is dA by A? That will be is equals to, we already know, dA by A is 2 epsilon dash plus what is dl by L, that is epsilon. That will be is equals to epsilon V. From that we can calculate the volume change, right? So this is the formula for volume change. So see, if it is a sphere, suppose let us say if it is a sphere with the diameter d, we applied some compressive forces press equally. Then because of that there will be some change in diameter due to these things. So how much will be that change in diameter? That will be change in volume. That will be equals to change in diameter divided by diameter into 3. Okay. From here we can say like this, right? So this is also equal in case of sphere. This will be 2dl by L in case of sphere. So that will be 3dl by L. That will be equal to 3 into dd by d. Now let us go to part C. So if you see part C, if the tube has a constant outer diameter of d2 75 mm. See, you see this figure. This is of 75 mm and that is constant along its entire length L. But now has increased its inner diameter d3. This is d3 with a normal stress of 70 MPa over the middle third. This is middle third. Okay. So middle third में d3 का diameter, the inner diameter is increased that to d3 with a normal stress over the middle part, while the rest of the tube remains at normal stress of 57 MPa. What is the diameter d3? With a normal stress of 70 MPa over a middle third. See the figure part B. While the rest of the tube remains at stress of 57 MPa. What is the diameter d3? So this is your homework question. So I think you can solve this question in the similar lines. With this we end today's lecture. In next lecture we will solve some more problems on other topics. Until then, take care. Bye bye from ninepointer. Thank you.